Yeah, absolutely. So first off, I just want to thank everybody for sharing their lunch hour with us today. I know you all have a lot of things you could be doing, so I'm glad you decided to spend that time with us. A little bit of background before I go into the material here. As Tom and Lars mentioned, I'm the founder and chief technology officer for Integrated Roadways. My background is in electrical and computer engineering. I've always been an internet nerd since before anybody knew what the internet was. I grew up in rural Missouri, and when it was time to start working, as you can imagine, in the mid-90s in middle of nowhere Missouri, there were not any technology jobs. So I went into construction. I could do it. I was good at it. The work was available and paid pretty well. So I spent about 20 years working my way up through construction, from labor to project management to management. And I saw that there was an inevitable convergence between technology and roadways. And this was the intertwining of road building with network delivery, with communications technologies, with information technology. And I wasn't the only one. Kiewit Construction Company started adding fiber internet or fiber lines to their highway services in the mid-90s. They built level 3 into a, I think, 5,000 mile network, spun it out for $5 billion. And it was all just on the insight that they already had the earth moved in order to build the highway. So they may as well drop some relatively inexpensive fiber conduit into the open trench while the construction was already ongoing. So level 3 merged with CenturyLink a couple of years ago to become the largest internet service provider in the world. So I knew that the internet was going to be combined with roadways for smart cities, for connected electric and autonomous vehicles. So I went back and got my engineering credentials so that I could be credible in talking about what that looks like and how to do it. So that's really the heart of the matter here for me, is a combination of decades of experience in construction and then learning all of the engineering skills behind the wired and wireless network design. And so that has led me to some realizations about some fundamental improvements that we can provide to one of the most common experiences that everybody has. And so that's the purpose of the talk today, is discussing how we can improve the user interface and user experience for roadways by taking advantage of smart infrastructure. Hold on one second. I do apologize. I need to fix something here. It looks like my slideshow is using timing, so I'm going to turn those off real quick. And now they are off, and I will jump right back into it. I apologize for that. I did not realize that I had timings on. Okay, so anyway, back to it. How can we improve the universal experience of roadways with smart infrastructure? And one of the things that we have all experienced is a bad roadway, right? Kansas City is riddled with potholes, and it's not just Kansas City. It's every city in the United States. About half of America's infrastructure is in need of fundamental repair right now. We're talking about millions of dollars per mile of road just to get things to a basic level of service. And what does that mean for users, the average everyday person out on the road? Well, the first thing it means is road closures for construction. These closures can be days to weeks to months to years. They are often unpredictable. The construction crew shows up at seemingly random times, does a seemingly random amount of work, and then vanishes for another random period. Modern navigation helps with this a little bit, but it's incremental at best. And when you have these wonderful road closures that none of us have ever complained about, you get these massive traffic jams. This is San Francisco. San Francisco is going to have a traffic jam whether or not there's a road closure. Kansas City, typically, you know, we get some backup on the Grandview Triangle, some other areas. For the most part, it's pretty free-flowing, except for very specific times of day and locations. But the point is, I've never known anybody to be excited about sitting in a traffic jam. It's a miserable experience. And then when the road work is finally done after seemingly forever, then what happens? Well, a utility comes along and cuts into the brand new roadway in order to service their line that they didn't service before the roadway was fixed. And there's a lot of reasons for that I won't really get into. But one of the most common headaches for public agencies is after they finish a major road improvement, the utility owners then file for permits to come in and tear up the road in order to access the lines underneath. Why? Did they get damaged during construction? That's actually pretty common to happen. The damage occurred during construction. The other part is that a lot of times they don't want to fix the utility before the road work because then the improvements could be damaged during construction. So from the utility's perspective, it's better for them to wait. But what happens when the utility cuts into the road? Not only does it lead us back down this chain of road closures and traffic jams, the end result is right back where we started with the terrible roadway, because cutting up that brand new road makes the road deteriorate at all of the joints and edges where the cuts were made. So after all this work and all this expense, we're right back to where we started. And the entire time, the public is just constantly complaining about how miserable it is. Now, this is not unique. Of all of the time that we spend on roads, or I mean on anything, this pie chart does not include sleeping, but basically we spend about a third of our time working, over an eighth of our time on social media, an eighth of a time on other leisure. Everything else is about a third of our time. But what we all do now until coronavirus is we spend about 5% of our time driving, an hour a day driving. And most of the time when we're driving, we're complaining about the quality of the road, road closures for road work, or the behavior of other road users, right? Raise your hand if you have ever complained about other people driving. All right, put your hands down because I can't actually see you anyway. So this is a universal daily experience that makes most of us angry and just miserable. And it's not like we can't do better. We can absolutely do better. The way we build roads was established about 100 years ago and has barely changed since then. We can build a lot faster. We can make it last longer. We can provide utility access and simplify the maintenance process. On top of that, paved surfaces, impermeable surfaces, are a huge impairment to the natural world. At this point, a significant percentage of the surface of the earth is covered by materials that do not allow water to flow through. And so we have these big stormwater runoff systems. We have declining water tables because the rain can't percolate back down into the earth again. We can fix all of that and implement sustainable design processes, but there's a big problem here. And it's the same problem that we always have. The question being, who's going to pay for it? Where's the money come from? Does anybody have the budget to pay millions of dollars per mile for the thousands of miles of roads in Kansas City in order to fix all of this? I mean, currently roadways cost about $2 million per lane per mile just for traditional products. And if you're talking about next generation solutions, you're talking about paying 2 times as much, maybe at a minimum. So who's going to pay for it? which means there's another piece that we need to improve, and that's sustainable financing. We've got to find a better way to pay. Now, you might be thinking, hey, let's do it the way we've always done it. Let's pay for it with taxes. But the question becomes, do you really want higher taxes? I mean, do you really want higher taxes? A lot of people think that fuel taxes are the primary source of revenue for roadways, and that's not actually true. Fuel taxes are split between the feds and the state. Most states, the feds have not raised the fuel tax since the 80s. Most of the states have raised their fuel taxes over the last decade or so, and there's been no tangible improvement in their roadways. Actually, even as state governments raise their fuel taxes, the overall condition of roadways has continued to decline. And part of that is because fuel taxes don't pay for city roads. We use a lot of state roads. We use a lot more city roads. And the thing is, the licenses, the permits, the fees that we pay for our car, that actually does not go to the city. That goes to the state. Property taxes. Well, most of your property taxes are going to the state as well. So the city really only has one way to pay for roadways, and that's primarily through sales taxes. Do you want your sales taxes when you go to the grocery store to be 3 or 4 times as much as they are right now? I mean, the cost of groceries has inflated significantly just over the last 6 months. Do we really want to add to that problem? And yet all of these groceries that we depend on travel across the roadway in order to get to the grocery store, and then you put them in your car and you take them over the roadway to get to your house. So we all need the roads, but raising taxes really only works in theory. And the reason for that is because the tax assessment for the roadway is significantly disconnected from the pain you experience and the people making the choice about how to spend the money, right? The city public works office, the Department of Transportation at the state level or the federal level, they have very different day-to-day experiences than you and I do. And on top of that, these taxes are extremely regressive because taxing fuel, taxing tires and oil and property and sales, that's actually a huge subsidy for big business because the majority of deterioration of the roadway comes from extremely heavy vehicles. So, you know, you can't create some kind of parity there by imposing taxes on the average person who doesn't really contribute much to the deterioration of the road. On top of that, you get vanity projects. Somebody builds a bridge to nowhere, like Sarah Palin in Alaska, who spent tens of millions of dollars on a bridge to an unpopulated island. You get vanity projects because it's always fancier to build something brand new and put your name on it versus fix something that's been around forever. So in the end, raising taxes doesn't really get you road improvements. Why do I spend all of this time talking about taxes? Because that is one of the largest user interfaces that the average person has for roadways. Taxes are primarily, other than driving on the road, most of your interaction with the road is through taxes. So I guess my point here is that we have a lot of seriously outdated techniques and designs for the way that we interact with and experience roadways. And the wildly outdated nature of these principles creates very bad experiences for us. I mean, imagine today trying to use Windows 3.11, which was the first version of Windows that provided network services. At the time, it was amazing. It was the best we could possibly have, but now it would be miserable. So if our operating system for our computers or our phones is only a couple of months or a couple of years old, why are we so tolerant of our operating systems and designs for our public life to be so incredibly outdated? A couple of the things that we can do to fix this is we can stop using bespoke design build. How many people here have custom tailored clothing? Some of you maybe, very few, right? I've got a couple custom tailored shirts. Yeah, they're great, but this shirt was made in a factory. Everything behind me that you can't see was made in a factory. And that's because we don't build things in place. We build them in factories and then we go buy them. It's a standardized product. So we need standardized designs. We need off-site factory-based production. These things are very old concepts, but they've never made it to roadway improvements, unfortunately. We also have very bad ways of limiting managing users. What do? We put an orange cone on the road. We put one of those barriers, and it has an arrow that says go this way. So we need integrated digital user management practices. And then finally, there's no cost control for changes. There's no way to actually limit the expenses that are imposed on society by modifying the roadway. So we need a feedback loop between the cost of something and the price of something so that we have better control over the holistic expense of the entire thing. Now, this is new for roads, but it's not new in general. On the left here, you can see one of the first patents for interchangeable parts. This was filed, I believe, by Eli Whitney in 1801. So interchangeable parts, factory production, those have been around for more than 200 years. There's no reason we can't use them. And then once you have the parts, you need a standard process for assembly instead of figuring it out on a site-specific, project-specific basis. Now, these are proven for the built environment. They're extremely common in vertical buildings where the use of prefabricated sections reduces the cost of construction by 30% or more. They are also common in bridges. You can see on the right these giant bridge components that are built off-site, trucked in, assembled, and it works wonderfully. My company, Integrated Roadways, we proved that we could do this 2 years ago in a project in Denver, Colorado, where we did a proof of concept for building roads from interchangeable parts with a standardized process. It's been up and running for the last 2 years. It's basically our development environment, right? When you have digital systems, you need a production environment and a development environment. Well, we had to build a smart roadway in order to get that dev environment. So we did that in Denver 2 years ago. The next step is to create those digital interfaces and the integrated financial management that we need. You see here a couple of dashboards that are, common single pane of glass management interfaces for internet assets and internet-based businesses. There are elements of this that are relatively common in the administration of roadways, but not anything that the users of the road can access. The admins get it, the DOTs and public works, but the actual users of the roadway are locked out. So we're building a first demonstration of this where the digital interfaces are available to the businesses in the area, as well as the users of the roadway. And we're beginning the implementation in Lenexa, Kansas in spring of 2021. What are we doing? Well, we're doing what we call a smart infrastructure showcase at Lenexa City Center. This is a partnership between the city, Kiewit, which is a $13 billion a year construction company that sees smart infrastructure as the future of their business. This is the same company, by the way, that built level 3 in the 90s by adding fiber to their highway projects. And now they want to take it one step further and make it a fully integrated process. And then, of course, Integrated Roadways, if the purpose of our name isn't obvious by now, I don't know if it ever will be. But anyway, we are privately investing about $8.5 million in this project to upgrade 5 intersections. You can see them indicated on the drawing here. These are 5 of the highest traffic intersections in the area. And we're instrumenting all of the lanes feeding into the intersections in city center so that we can monitor all of the traffic in real time, load that into the digital interface hosted on the cloud, and record and display the full traffic history. You might say, you know, what good is that? Why does a business in the area need to know the traffic history and the real-time traffic for the area? Well, let's think about one of the most common businesses, which is the restaurant. Around city center, we have a bunch of different restaurants. These are not the only ones, but there are a couple of the obvious ones. All of these restaurants, they access users, they access buyers, customers, clients through the roadway. Some people walk up, yes, that's true. Most people that get to these businesses get to the business by the road. That's why you have the parking garages, the parking lots, because these guys are utterly dependent on traffic in order to operate their business. Look what happened with coronavirus. Traffic collapsed, businesses collapsed. Yelp says that more than 50% of their businesses that they have listed are out of business permanently. They rely completely on traffic. And you know who else relies completely on traffic? Well, websites do. Facebook and Google, how do they make their money? Well, they make their money by monetizing traffic data, but it's internet traffic data. So let's do a comparison here. When you build a website, you're going to spend 5 to low 6 figures. And if you're at the higher end, you're going to get an amazing website. And it costs, you know, 3 to 5 figures to run it for a year. It's very modest, very reasonable. Whereas a restaurant is going to cost you $250,000 to $500,000 to get it going. And then you're going to spend $1 million plus in order to run that restaurant. And both of these businesses are dependent on traffic information, but for the website, they get free traffic information that is extremely data rich, whereas the restaurant, in order to get traffic data, they have to pay $1,000 every day for every leg of every intersection. And the data is miserable. It's a single number. It doesn't tell you any demographics, any behaviors, even time of day. It's a count. It's horrible. So our goal here is to bring traffic analytics to brick and mortar businesses so that they have better competitiveness and better viability against online retail like Amazon, or against you know, any other sort of brick and mortar competition they may have for restaurant sales. And there's so much that you can do here. Now, you might think, well, they already get that data, because if they have a point of sale system like Square, they're getting information about transactions. And that's true, yes, kind of, sort of. The difference here is that, and this is a Square dashboard, by the way, transaction data is a lagging indicator. And what do I mean by a lagging indicator? Well, the transaction is the very last step in the entire chain of opportunity. Okay, so after you've had the transaction, yes, you know a lot about the transaction that you had, but you don't know anything about what happened before that, because you don't have any data collection until everything is done with and you have the transaction finished. Traffic data is a leading indicator. The indicator for traffic happens before any kind of user interaction. Why? Well, logically, you have to drive near the restaurant before you can stop at the restaurant, go in the restaurant, order something, eat it, and pay for it. So traffic happens first, transaction happens last. So what we're doing is we're turning roadway traffic into a leading indicator for one of the primary commercial users of the roadway, which is restaurants and other retail businesses that are in the area. So the goal here is to treat traffic, road traffic, like internet traffic. So you can have traffic-driven monetization of the road improvements, traffic-driven optimization of the road improvements. You know more about the sources of traffic and how the traffic is using the roadway. And because of these improvements, the traffic pays for the road. Right now, road traffic is a liability. It imposes an expense on the owner of the road, and then the owner has to go back and raise taxes in order to pay for the expense that was imposed by the traffic. What we're saying is treat traffic like web traffic, and now the traffic is directly paying for the road, which means the road's budget is based on its traffic, and the roads improve directly based on feedback. So we're creating that feedback loop that I mentioned earlier between the cost and the price. And all of this together provides for better design and management at every level of service. A simple way to think about this is by the graphic on the right-hand side. Right now, you have the real estate underneath the road, and then you put the road on top of it. And in current practices, that's where it stops. Real estate, roadway, done. What we're saying is add the technology delivers a network, the network provides services, the services run applications, the applications generate transactions, and along this entire flow, you have data, and the data is itself fundamentally valuable. So it's looking at the integrated whole of how the user interacts with the road and how the user experiences the road in a modern context, taking advantage of all of the tools and knowledge that we've generated over the last 100 years that we've been paving roadways. So there's a lot we can do to improve the UX with data. On the public side, we can better plan developments. Right now, when a developer is planning on building a new property, they have to go through this rigorous development planning process with the municipality. They're dealing with really bad and outdated data. Collecting the data is crazy expensive, and the data that you get is not good data anyway. So we can dramatically improve the development. We can improve the planning for roadways so that the roads that we get are in better position, better design, better managed. All of this leads to better signal timing because the control systems that are implemented into the road can be significantly more responsive to traffic. And because all of the data collection and signal timing can be digitized, then we get better traffic alerts. You can, from the public side, for everybody that's on the road, you can dramatically improve the knowledge that's accessible by navigation and other services. Now, on the individual side, for private operations, I'm going to focus here mostly on a business, right? And businesses need to know when they're going to have customers so that they can plan how many people they're going to have working. Right now, it's kind of a crapshoot. They really base it on their guesses. There's not a lot, there's a lot of work that goes into it, but there's not a lot of data that informs that work. So if we can improve their staffing, then we can improve and optimize the operation of the business. We can give them better revenue projections by allowing the correlation between the leading indicator of traffic and the lagging indicator of transactions to predict what the business is going to do, how it's going to perform in the near and far future. And then we can enable better marketing and advertising for these businesses. The classic saying is, we know half of our marketing budget is wasted, we just don't know which half. Well, this allows businesses, brick and mortar businesses, to improve their marketing and advertising in the same way that web-based businesses do. And then finally, you know more about your customer, and because you know more about your customer, you can make a better offering. You can match what you are providing to them and what you're charging them to the demographics and the expectations of the clients a lot better. So I've spent most of my time talking about data collection. And it's not just data collection. Data collection is step one, but in order to plan for the next generation, we don't need to just service the needs of today. These roads are going to be in place for 35 to 50 years, so we need to predict what's going to happen over that time. So next generation roads need everything I've talked about, and we need plugs and wires. Look around the room. There are plugs about every 6 to 12 feet in every wall that surround you, whether you're in a commercial property or a residential property. And we build houses and buildings with plugs all over the place because you can't predict what somebody's going to plug in and where they're going to plug it in. We don't do that with roads. Right now, when you have a smart city project, the majority of the cost of the project is getting the plugs and wires in the right place. So by building the plugs and wires into the core delivery of the road improvement, you save a ton of money in the future because it's already out there and you just have to plug it in. We need wireless communications, right? Like our entire world depends on Wi-Fi and cellular. Our roadways do too. How often have you been driving around and you're on a call with somebody and you drop off the call because of bad service? Well, that's annoying but tolerable whenever you're the one on the call. But if you're in an autonomous vehicle and that vehicle loses its signal and now you're stranded, that is not only annoying, it could be dangerous to the health and safety of the occupant of the vehicle. So we need wireless communications built in from the start, ubiquitous and universal everywhere a road goes. We need edge hosting, right? Because a lot of us are not just on a call. If you're a passenger in a vehicle, maybe you're watching Netflix, right? Or maybe your car is autonomous and it needs mapping. And all of these things are extremely data driven, and you need local hosting right there at the roadway in order to accommodate the data that the vehicles and users are going to need. We need wireless EV charging. I don't know how many people here keep on top of the electric vehicle market. Tesla has not even sold 1 million vehicles. Well, I think they cleared 1 million earlier this year. So they've sold about 1 million vehicles. And their charge system, they spent billions of dollars building out their supercharger network. And yet on holidays, it gets clogged up. Thanksgiving, Christmas, you're going to spend hours waiting to charge your vehicle. Well, I'll talk more about wireless charging here in just a moment. So we need wireless chargers. Let me leave it at that for the time being. And then, of course, we need navigation to enable autonomous vehicles. Autonomous onboard vehicle navigation has been the modality for autonomous development for the last 15 years, and it's absolutely wrong. Why? Well, does your cell phone work without a cell network? Does your computer work without an internet connection? No. Heck, your TV doesn't work without a network connection, whether it's broadcast or cable or Roku or Netflix or what have you. Advanced digital technologies need networks. And so autonomous vehicles need network-enabled navigation services in order to move from level 3, which is advanced cruise control, to level 4 to level 5, where the vehicle is completely self-operating without any interaction with the driver. So our system is designed from the beginning to deliver this. For distributed antenna systems for Wi-Fi and 5G, for example, you need cabinets for the IT. Well, we got that right here. You need fiber and power access. We have that at the cabinet and in the pavement. And then you need antennas every couple hundred feet. Well, we have that directly in the pavement. It's built in, it's upgradable, replaceable, modifiable. And so at any time over the life of the roadway, you can come and put in antennas, put in sensors, put in whatever you need. Finally, wireless charging. By upgrading 5 to 15% of the roadway with wireless charging, there's never a wait to charge because it charges as you're driving. It's just like running over a power up on Mario Kart. You can leave home without a full battery, charge on the way, and by the time you get there, you're fully charged. The capacity problem is solved because you don't have to pull up to a charge unit and plug in. The capacity to charge vehicles is equivalent to the capacity of the roadway itself, which means you're never going to have more demand for charging than you have supply of charging. This also makes the battery size for when you're not on a charging roadway, which means your 300 miles in a Tesla is 300 miles off of the interstate, which dramatically improves the distance that an electric vehicle can go. And then finally, the battery cost is one of the largest expenses for an electric vehicle. So if we can deliver a smaller battery, then we can deliver significantly less expensive vehicles. So there's certainly a lot more to say than I've been able to cover in 30 minutes. And I sincerely appreciate your attention and time in the 30 minutes I've had. But I do want to open the floor for some Q&A. After we're done with Q&A, if there's any more discussion to be had, you can reach me to talk about technology. You can reach David Good, our marketing officer, to talk about marketing. You can reach Miguel Jaramillo, our director of business development, to talk about the business side. Or you can go to showcasecitycenter.com and learn more about the project we're doing in Lenexa. That said, I want to open the floor for question and answer.
Thanks, Tim. That was awesome. Really fascinating stuff. Shoot away. Anybody got any questions? I have one question.
Yes.
So you're putting in integrated roadway sections into 4 intersections down in Lenexa. Is the idea that you put in these sections at different points, or is the long-term goal is to convert all roadways into integrated roadways everywhere?
Well, right now, the United States has 8 million miles of roadways, and only 5 million of them are paved. So I don't think all roadways are going to be smart, at least not anytime soon. We're probably talking about the top 20% upgraded over the next 10 to 15 years, and probably the top 40 to 50% upgraded over, say, a 30-year horizon. So it's driven by traffic. And you might be thinking, oh gosh, you know, what are we going to do about those other roads? Well, the current sources of capital for roads are not going anywhere. So any road that we can improve based on cash flow from services means that the money spent on it right now can be reallocated to better management of traditional roads. So anyway, Tom, just to be a little more explicit, we do expect that, you know, probably we'll start with upgrading thousands of intersections. And then as those intersections come online, we grow between the intersections with wireless charging, with autonomous lanes, and eventually the intersections in a city are deeply connected. And so we grow between cities with highway and interstate lanes. And then, of course, upgrading all of the ramps in between as we go.
Nice.
Yeah, so we got another question in chat. Dave Nickel asked what other projects are underway or being contemplated. So as of right now, we have a backlog of about 800 intersections that owners have asked us to do improvements to. Those intersections, moving forward on those projects, are gated, and they're gated by proving the financing and proving the revenue. And we're doing that with Lenexa. So in order for a private investor to fund a roadway, they have to have a 12% to 15% return. To be the first person to do it, you need more like a 20% annualized return. And so we have to prove with Lenexa that we can get to those high risk, high return scenarios and have them proven out. And that gives us access to the financing capacity we need for about $800 million to do the additional 800 intersections that are currently backlogged. There's 800,000 lighted intersections in the United States right now. 8,000 of them would be the top 10%. So first we do the handful in Lenexa, then we do the next 800, then we do the next 8,000, and away we go. Jacob asked, what ethical or legal issues would you have with collecting data on drivers? How similar would it be to collecting data from the internet? Jacob, great question. One that we deal with all of the time. And the takeaway here is we are not collecting personally identifiable information. That's the biggest difference. When you're online, they know exactly who you are. When you're driving on a smart road, we don't know who the driver is. We don't read faces. We don't read license plates. What we do is we use the dimensions and the weight distribution of your vehicle to figure out your make and model and your production year range. And then we combine the make and model and production year range information with sources that tell us the probabilistic distribution of demographics for ownership of those vehicles. And that gets us to the point where the data is incredibly valuable from a marketing and advertising standpoint, but does not reveal any personal information about the driver or an occupant.
Wow. So is that the extent of the data that you pull?
Well, when you connect, when you use wireless services, then in order to access that service, whether it's Wi-Fi or cellular, then we have, not we, but the provider of the service has access to an increased level of data that is currently being collected from your current Wi-Fi or cellular provider. So there are occasions when there is the capacity for personally identifiable information to be collected, but the capacity to do that is no different from what is currently done with Wi-Fi and cellular in other contexts. So as a user of the roadway, there's never personally identifiable information. As a user of communication services, there is personally identifiable information equivalent to what's already being collected. But it's not necessarily being collected by us, it's being collected by whoever's running the wireless network that you're connected to. So David Good asks us, can the data from one location be valuable to other locations? And the answer to that is absolutely. In advertising, you have this concept called lookalike audiences, where you find groups that have similarities. The city of Lenexa shares a lot of similarities with other suburbs in other municipal areas that have comparable demographics. And so whether it's a suburb of Denver or LA or New York or wherever, when you find a lookalike municipality, then the data from Lenexa is comparable to what you would expect to see if you had systems implemented in that lookalike municipality. So you get the data, you say, hey, this looks like Aurora, Colorado, and you can provide useful data to the denizens and the managers of Aurora. And then they say, oh my gosh, you know, this lookalike data is amazing, but it'd be even better if we had our own unique data. So why don't you come out here and put your system in our intersections so that we can have our own data too? So yes, there's an immense amount of residual value that can be applied nationwide and eventually worldwide just by identifying audiences that are similar to the audience we have. So Lars asks, with the project in Colorado as your dev location, what have you learned since then? And how have you been able to apply the integrated roadway technology? Great question. So what we have been doing is building the basic data analytics. Until we actually had a live site with real traffic in a real roadway, our ability to analyze the data being collected was super limited because, I mean, we didn't have it, right? How do you analyze data you don't have? So implementing in Colorado gave us 2 years to build out the analytics so that we could be sure that the traffic collection was working, that we could measure the dimensions of vehicles, that we could weigh the vehicles, and that we could do this at an extremely high confidence level so that we know that the data is good and accurate and useful. And then how we've been able to apply the tech. Well, we didn't necessarily realize at the beginning how useful weigh in motion systems would be from this kind of data. So by being able to weigh the vehicles driving across the roadway, there's an enormous amount of additional opportunities for that. For example, by eliminating weigh stations. Commercial shippers are limited to 10 hours a day per driving, and they spend about 2 hours a day waiting in line for their truck to get weighed. It's ridiculous. So by doing weigh in motion and communicating the vehicle weight directly to the vehicle and back to the relevant authorities that need the weigh in motion for monitoring purposes, we can give the driver back 2 days worth of driving. 2 hours worth of driving per day, which is a 20% improvement in the distance that a commercial truck can reach in a single day. That's enormous. All right, anybody have any other questions? I could do this all day, so don't be
Yeah, another question about your application that you're developing. So presumably with the work you're doing in Lenexa, you're building the dashboard application. How's that going, and how's funding for that going?
It's actually, it's going fantastic. The idea of building a single pane of glass management facility, or observation facility, I should say, and then tying that into a user account management system, and then merging that with subscription-based access. Software as a service has already done all of these things for us. Now, it's done it for pure play digital assets, right? Running an online service, whatever. But these utilities are resilient. And so what we're basically doing is taking things that have already been done on the internet and then just merging them to our source of data from the hardware installed in the roadway. So right now we are in the demonstration mode to stakeholders, and we're going to be releasing that to a paid user access level as the Lenexa improvements go live. Some stakeholders are going to have early access. The relevant regulating authorities, the financiers of the project, the builders, some of the commercial users that are going to be buying the data. And then once we have Lenexa up and running, we throw the gates open, and anybody that wants to access the data service, you create a user account, you put in your payment details, and away you go.
Okay. And how can we stay up to date with progress?
Well,
through your website, or?
I'm sorry, go ahead.
Through your website or something else?
Watch the news. No, seriously, who watches the news these days, right? Right? You can see our website, you can see our LinkedIn pages, our Facebook pages, our YouTube pages. You can go to Showcase City Center. If you're truly civic-minded, you might show up to a Lenexa council meeting and see us in the flesh. If flesh-based meetings still exist in this future world we're living in, but there's there's certainly going to be no lack of opportunity to keep tabs on us. And you know what? If you want the latest and greatest, go to news.google.com and search open quote integrated roadways, close quote, hit enter, and you'll have more information than you could ever wish to dig through.
Okay. Any other questions for Tim? I could probably do this all day as well. It's fascinating.
I get it.
Tim, it's Mike Farley. Great stuff. It's really, really exciting. I'm so excited to see the project coming here to Lenexa, right around the corner from us. But just know, you know, like we've done in the past, I'll be happy to support any future meetings you have with the city council and things of that nature from a network connectivity and a network assurance perspective.
Absolutely, Mike. We appreciate that. I'm so glad that you can make the presentation today. Thanks for coming.
No problem.
Last call for questions. Lars, did you have something there? Or no? No.
Nope. Just excitement about the concept.
I do have one final question for me. Is do you have any competition in the space?
Funny you should mention that. Just last week, Google announced a new company called Cavenue that is going to be upgrading 40 miles of interstate between Detroit and Ann Arbor using smart infrastructure technologies. So if you asked me 2 weeks ago, I would have said, in theory, yes. In reality, no. But you know what? It's hard to have a better competitor than Google. That brings an enormous amount of credibility to the market when you say, yeah, we have a competitor. It's Google, and they are years behind us.
Right. You have the upper hand then.
Yes. Now, you know, the easy part is getting it. The hard part is keeping it.
Yeah. Well, guys, this has been great. Thanks so much, Tim, for taking an hour out of your day to talk to us about integrated roadways. It's fascinating, and we wish you all the best with your work and the project down in Lenexa. We'll certainly stay up to speed with what's going on down there.
Absolutely. You know, as we advance, I'd be more than happy to come back and, you know, share updates and show demos and whatever else we can do. You know, we usually don't think about the user experience and user interface for roadways. And it's just so much fun being able to bring this kind of stuff forward and show people how important these concepts are for our daily life.
Right. You have a team of UX designers on board with you?
You know, slowly but surely, we're adding talent every day. We are looking, by the way, I should have said this while everybody was still on, probably should have brought it up earlier, but we are looking for additional assistance with UX, UI, and some of the other front-end technologies. So if anybody's interested, hit me up at tim@integratedroadways.com and let's talk about it.
Fantastic. Well, thanks, guys, for coming on board today. It's fun to see you all. Mike, Lauren, Jacob, Erin, Dave, DJ, Bob, Nick. We have recorded this, so we'll put it up on our YouTube channel. If you haven't subscribed to that, you can subscribe and get updates. We post all of our presentations up there. Our next event coming up is with Michael Eckersley from the University of Kansas, and he's going to be doing Act 2, Growing and Sustaining a Design Career, which we're really excited about. And then we have another happy hour next month. These are going to be on the third Wednesday of every month, so be sure to register for that. So see you guys the next time. I hope you all have a great rest of your week and enjoy this beautiful weather.
Thank you all. been my pleasure.
Thanks, Tim.
Thank you, Tim.
Thank you, Tim.